Не знать, и более того, это может быть не определено. Этот номер может быть, ну вот,
Да,
плавающий.
я могу, да, вот это вот.
Номер для
Допустим,
пустых
что у меня,
вещей.
да, есть, вот, ну, грубо говоря, конкретно. Я вот знаю, что вот сейчас у меня вот Space готов, потому что я добыл что-то, да, вот он в таком состоянии, в котором готов корт, и тем более, если я хочу после этого, чтобы корт случилось.
Ну да.
И вот я к этому не придумал никакого хорошего интерфейса для стресса. Я просто не понимаю, что там
Ну,
делать.
у нас есть время подумать.
Ну, как вообще это сделать, да? То есть Trace, только если что-то какое-то вешать, то есть.
Ну, с Windows сделай.
Я не знаю, как.
Не, интерфейс всегда сложно придумать. О, спасибо. А это для следующего. А то просто вот под конец пересыхает все.
Значит, смотри, просто включаю вместе. Вверх на мониторе. Все.
Давай. Погоди, а ноутс? Ноутс хочу, ноутс.
Не будет у тебя нового? Все.
В смысле, сделай ноутс?
Oh, perfect. Okay.
Yep.
So this clicker, if you want to use it,
Ну, потому что я так не знаю.
you can add on. Nice. Try that.
Как можно с вами познакомиться? Да. И Евгений.
So we're about to start. Finally, our technical issues are resolved. Please turn off your phones and don't forget to vote for a favorite talk. And please welcome Elvira and Evgeny.
So I'm gonna talk about another new feature in Strace, not yet merged, but will soon. Truly structured output in Strace. Strace, well, Dmitry already told you about Strace and how it works, and this is typical Strace output. As you can see, it is pretty C-like since 1991, but actually it's not C-like, it's more human-readable. It appears C-like. This is how syscall decoding is implemented. This is a prototype of a syscall, get itimer. It is used to get itimer value in this pointer. This is the decoder. As you already know, Strace interrupts the tracer twice. First on entering the syscall and then on exiting the syscall. So this is what happens on entering, and this is what happens on exiting. These two functions, print xval and print itimerval, first fetch and then immediately print the values. The second value, car value pointer, is a so-called out value. This is where the kernel returns the value. This is why we have to split the decoder into parts. On entering, we print what we can print, the first half, and on exiting, we print the second part. As you can imagine, if there are in-out arguments or multiple out arguments, it gets pretty messy. We have to stash values somewhere if it's not properly split in half, etc. Also, you can see here that every syscall parser has to print various commas. We can accidentally forget to print commas, and well, all this code looks pretty bad. This is another syscall parser. Here we print a complex struct. Everything is printed by hand. this is bad. This is very bad and redundant. So what I told you about not actually being C-like. This is except for, and the third argument is an in-out argument from the main page. The header-len argument is a value result argument. The caller must initialize it to contain the size of the structure. On return, it will contain the actual size of the peer address. This is the send-to syscall. The first value is a socket, and this arrow is not an in-out value. This is the listener and receiver, IP and port. And this is the listen syscall, and this is not an IP or a port. This is an inode of the socket. This is set timer. Nested structs. The outer struct doesn't have a name, but the inner structs do have names. And the fields of the structs don't have names. RT sigprog mask. The third argument is not actually an array, it's a bit mask which has, to fill it we have, the kernel has special functions, but it's printed like an array without commas. This is then exactly, it's not even printed properly. So what's the problem? People try to parse this. This is PyStrace, a tool to convert strace output to an easy-to-parse CSV. Unending struggle. To properly parse everything, these parsers have to re-implement strace almost. This is strace to CSV. Regexps again, eternal suffering. This is something in Perl for change. This is in AVK. This is actually used in buildrec, a program from Alt Linux used to fetch build requires. The entire build of a package is straced, and then the strace output is parsed, like this. Strace doesn't only print syscalls, it can dump data. Minus e write equals 1. It can print syscall statistics. Note the errors column. There are no zeros, but the microseconds do have zeros. What if people try to parse this? So we have to separate parsing and printing. We need a whole new approach. Eugene, come here, tell the boring part.
Well, for the boring part, as you already seen, the syscall, the strace output is human-oriented. It is human-oriented on purpose. It originally meant to be read by humans and is not intended to be read by machine. As a result, it has a lot of peculiarities. And all the strace decoders have been written with this idea in mind. There are a lot of decoders as a result, which just print the output in human readable form. Read it and print it. So in order to get ability to have printed in some other form, we should split fetching of argument data into some internal form and printing it in some form which could be human readable or machine readable or whatever. So as already said, decoders try to do everything, and inherently it is bad because, well, they printing commas and stuff, and it would be much better if we free them from this burden and make all syscall decoders just do decoding, actually, and add some printers which would do printing from some internal representation. So parsers should do only one job, and printers themselves should be as local as possible, because now the trace itself prints the trace core code, prints something regarding when it handles ptrace error codes, when it handles exits, when it handles everything, it prints something, and decoders themselves print something, and it should be done. It is done currently in some synchronous way. So we're taking account that the brackets already printed, the line return is printed or not, or have we printed something since we do the line return or not, all the stuff. And in order to do this, we have to introduce some middle layer, which, from one side would pack the decoders, and on the other side, which allows the writing code format as well. Quite trivial. So currently, all the syscall-related information is stored in tracee control block. It already contains data which is retrieved by strace, such as syscall name, which could be different from actual name now, since actual syscall ID now, since here is fault injection took place. Here is retrieved argument, arguments themselves, but not the data to which argument points to. It is the job of decoders to retrieve, and so on. So it is augmented with some storage for internal representation of this argument, and in addition, some state is added which allows decoders to, which frees decoders from tracking current printing states themselves. For example, whether we're in structure, whether we printing the one argument or another. For example, some system calls have arguments of type long. On 32-bit architectures, these arguments occupy 2 registers, or double the stack space. On 64-bit architectures, this argument occupy a single register. So when you're trying to print this argument, you should handle somehow this fact and calculate the number of the next argument depending on the architecture, at least in code. So what this internal representation does is it is basically enables storing each entity which has its own peculiarities in printing as a separate type, as entity of separate type. So in order to enable formatter to handle variations in size, in signedness, in formatting itself, for example, should it printed in hex or octal or anything else, or more interesting, for example, if you're trying to print user IDs, then usually you have one special value, -1, which is invalid value for one syscalls and the special value for other syscalls. But nevertheless, in both cases, it is special value, and it's better when it is printed as -1, and strace already does this. And we should account it because, Otherwise, the user ID is unsigned, as example, is unsigned itself, and well, for example, -2 is should printed as 4 billions and something, and so on. So in order to allow to use these types, appropriate API calls are added, and not only for some basic types, well, which allows parse arguments as entities with some semantics, but also for typical types, well, which already has implementation in trace, like time-val, like some structures, most of the structures, socket other, statfs, well, there are plenty of them. And, well, some miscellaneous AP calls for, well, handling all the stuff. Well, and the formatters themselves implement rather trivially as a set of functions, and in order to select one formatter or another, just pointer to structure containing pointers to this formatter should be set, and then trace just calls them via, well, this pointer. So, well, how it looks like. There is some called decoder, well, similar to one you have seen already, which instead of printing some values directly, now pushes this data into some internal representation, which is, well, some linked list, which can point to different internal structures. For example, swap flux is a value which has two parts. One is flag and another is swap file priority, and it should be decoded accordingly as a set of flags and some value. So, and then this internal representation can be parsed by various decoders in order to print actual output. There is legacy decoder, which prints totally the same, and the JSON decoder, which just dumps this representation in some, well, JSON schema. So, well, as I said, there are, well, most of the API calls is just insertion and pushing. Well, insert something is, well, insert something at current insertion point inside structures on arrays or something, and push is a shortcut which allows, well, push yet another argument and move pointer to current argument to the next argument, depending on the argument size. For example, as I described the issue with long. So there is additional handling of arrays, and in-out arguments, they also need very special treatment because, well, on exiting we would like to also have some easy way to say that, well, this argument is, well, I like to push next out argument and then next out argument and something. And, well, something miscellaneous like pushing empty arguments is for placeholders because, well, for some architectures or some cases there is arguments which are, well, there are arguments which are not actually used, or ellipsis, it's just, well, artifact of current implementation of legacy decoder because arrays should be terminated in accordance with current max starlen value, and it's currently a way to implement this. So the aforementioned swap-on decoder is well, originally was like this. You can see that there is the issue with flag parsing. So if there are flags that we parse them and then print priority, or well. So you see, it's very well, as you have already seen, it was very peculiar code, and now it can be more straightforward. And there are many other examples where decoders became easier, much more easier and straightforward due to this conversion. And this is example of some JSON, well, which is actually readable. It's example of getRandom output. So what can be seen there? Well, basically, I don't know, because it doesn't matter, because the JSON schema itself is just dump of current internal representation. And current internal representation, for example, has some non-stabilized features and so on. So, well, it is not even documented, so it doesn't matter how it looks like. Well, yeah.
Back a slide. When traces the program, these blocks of JSON are printed live. This is the first thing I want to note. And second, JSON and traditional output are not the only options. If we see an example of some other printer driver, we'll implement an option to load the printer as a library, so CSV, whatever.
So, well, what now enables the structured output? It, well, enables less redundancy. It enables, well, since all decoders are touched in any way, it well, also allows, well, do some code polishing and, well, finally write some argument names, add some argument comments, for example, for some CTL or KeyCTL, EOCTL, well, PRCTL and other decoder syscalls which are just dispatcher syscalls, and nobody remembers, well, what arguments actually meant without looking up the man page, but there is currently no man page, for example, for KeyCTL syscall. So it enables implementation of some new features, and the struggle finally ends, hopefully. So, well, it's not finished yet, and the current effort is sort of shifted, because, well, when it started, it's realized that, well, in order to bring this to the master, all syscall decoders should be covered in tests, and it is not the case currently, and so on, and basically that's all. So thank you. This is address of a repository, which is where the work is done and which could be inferred, so you're welcome. So any questions?
Question one.
Well, yeah.
So how do you handle in a multi-process S-trace when at the moment you have two lines where the call starts and then subsequently it ends? How's that handled?
So how multi-process is handled in S-trace? Well, this S-trace itself handles multiprocessing in the way it sequences them. So it already handles all the issues with which multiple processes, like, well, one system call is started but and process has gone to sleep, but there is another one. The strace already handles it.
Strace already can print output for various processes to various files, to different files.
I mean, do you get one internal representation object, or are two emitted, and are they? Is it easy to correlate them?
So the question is whether there's one internal representation or multiple. Okay, so each process has its own tracy control block. So when there are multiple processes, there are multiple tracy control blocks, and each process has its own internal representation of the current syscall. So,
the last question. When this shiny stuff is going to be available for medium user?
The question is when this would be available. Well, it's a tough question because, as I said, the work on this branch is,
it's hard
inspired some changes in the master, and when you change the master, it means that you should rebase the development branch, and
we have to constantly run after you, merging new features in master. We have to rebase and rebase.
It's going to be available for medium user. And now you explain why you have difficulties. It's not the question.
So my expectation is like something around 4.17, 4.18 release. Not earlier.
Thank you very much.
Yeah.
We have to be prepared for the next speaker. Thank you a lot.
I'm really sorry.
Yeah, no problem.
Oh, yeah.
No, I can myself. I'm wondering, microphone. I guess I have to use it, right? Yeah. Okay.
Is there any problem with microphone?
Sure.
Is there any problem with microphone?
No, it's fine, but I'll get used to it.
Yeah, I understand that. I don't like to use the microphone.
Yeah, it's like, when Adrian dropped that a couple of times, I'm
Yeah,
very
well,
sure
we
you
can
have to
actually
as well.
No.
Either
Either behind or put it into the pocket, and that would be okay. You can put cable in the pocket, or you can just
Yeah, exactly. So you can actually
What's
prepare.
the best place for the microphone?
Oh yeah.
Yeah, that one is good. So maybe a little bit lower.
Lower?
Just a little bit. Yeah, that would be good. So can you try?
Okay, 1, 2, 1, 2, 3. Okay, thank you.
Perfect. So it's muted. Just flip the switch when you're ready.
Right now it's muted. Yeah.
Alright. I guess you've got a phone in that same pocket. Alright. That would be
That's a
the
very
main
good morning.
connection. Now, would you prefer VGA, Steve?
VGA, please.
Yeah, VGA. So
right
you can.
here.
It's always better. We had
Yeah.
all the troubles with HDMI.
Troubles with HDMI.
Yeah.
No problem. If you change it correctly.
Let me try to see if I have some slides here.
Alright, just to remind you,
Okay, I'm
the screen is 4:3 aspect ratio, so just use appropriate resolution for that one.
Okay, so what we can do 4:3, so it's
Like that one, or okay, that would be
this one.
Yeah. Definitely.
Wow, it's much better than mine. Oh, here it is. Okay, that could work.
Perfect. Have you connected the clicker? Just a USB, Bluetooth,
It will
drive,
work
and you
right
can
away.
just, yeah, plug and play.
I need to go use the arrows because it's Firefox. It works like this, and sometimes I need to go down.
Ah, alright.
So
okay.
page up, page down, I guess.
Yeah, page up, page down, either left or right. I'm not really sure which
can
key
try, we
codes
have-
actually use it.
I would rather stay with this one and
Yeah.
somehow deal with it.
Yeah, no
Okay,
problem.
but,
We can
1
right
minute.
or left.
You have plenty of
Perfect
time.
timing.
Right,
Perfect
yeah.
timing
How
for
are
you
you
guys.
Water?
Now I'm thinking of moving the laptop more there so I can actually walk, run.
Bit of a speaker
Power.
drill before we start. So you've got